Okay, welcome again to MA 1203 Business Mathematics 2, and we will continue our discussion of first order linear autonomous differential equation, but this time we have initial values for those differential equations. Okay, so now remember before we already discussed that here if we have a differential equation which is a first order linear and autonomous, so in general we have y-axis plus ay equal to b, right? Then the solution will be yt equal to the homogeneous solution, which is c e to the power of minus at, plus the particular solution, which is equal to the steady state value, which is b over a, right? And then of course, if we have an initial value, say y at t0 is equal to y0, then we have yt0 is equal to y0. So this is y0 equal to c e to the power of minus a, we change t with t0 plus b over a. And then of course we can solve this for c. C will be, we move b over a to the left, or then we can have c, we have to divide both sides with e to the power of minus a t0, and then altogether we have, this is the c. And if we put the c into the solution, we will get this. The c we put back into the solution here. Okay, or we can do some manipulation here. We collect e to the power of a t0 and a to the power of minus at, and we will get this, right? But remember, b over a is just the steady state value. So we can rewrite this in steady state value. Just change b over a into steady state value, b over a into steady state value. So this is the solution when we have an initial value. But of course, you don't have to memorize this. We can find the constant by just substituting, of course. Okay, so let's see this differential equation. Y-axis equal to 0.1, y equal to 1. And we have an initial condition y0 equal to 5. Okay, let's rewrite this in the standard form. So what is it? Y-axis minus 0.1 y equal to minus 1, right? Okay, so the solution will be equal to the homogeneous solution. Homogeneous solution, remember, we just have to change the right hand side with 0. And the solution of the homogeneous form is c e to the power of minus a. Here a is minus 0.1, so 0.1 t, plus what? The steady state value, which is the particular solution. So the steady state value will be minus 1 over minus 0.1, and this is equal to 10, of course. So this is just c e to the power of 0.1 t plus 10. Okay, so this is the general solution. And how to get the c? You just have to substitute. So here you have y0 is equal to 5. What does it mean? Just substitute for t equal to 0, the y is equal to 5. So 5 equal to c times e to the power of 0. E to the power of 0 is, of course, 1. So just c plus 10. And of course, here you have c is equal to minus 5. All right. So putting it back together to the solution, we have yt is equal to minus 5 e to the power of 0.1t plus 10. Yeah, so this is the solution where we can get rid of c. Yeah, we can eliminate c because we have the initial value. Okay, so let's go back to the example that we have before. Yeah, this is exactly the same problems, yeah, except that now we have the capital stock at time t is equal to 0 is k0. Yeah, so remember, yeah, you can look it up, yeah, into your notes or into the video. You can play it again. Yeah, so we have the solution for this problem before is c e to the power of minus delta t plus I bar over delta, right? Yeah, how to find this, just watch again the previous video. Okay, so now we have at t equal to 0, we have k0 is equal to k0. Yeah, okay, so what happened here? So k0 will be equal to c e to the power of 0, which is 1, so leave it that way, plus I bar over delta. Yeah, and of course here we have c is just equal to k0 minus I bar over delta, right? Okay, so we just substitute in the solutions that we have before, and the solution will be k0 minus I bar over delta times e to the power of minus delta t plus I bar over delta. Okay, yeah, so this is another example, and the last topic will be about convergence of steady state value. Yeah, so now we want to know, yeah, whether the system will converge to the steady state or not. Yeah, okay, we can have the solution. If we have initial value, yeah, the solution will be this one. Yeah, yeah, this is a couple of slides before. Yeah, you can go back and see, yeah, how we get this. Yeah, so this is y0 minus y bar e to the power of minus 80 plus y bar. Yeah, and now we want to know what happened when t is getting larger and larger. Yeah, so basically we want to know the limit of the approaching infinity of yt. Yeah, all right, so we want to know what the limit of this, right? This is the limit, this function here. We want to find out what is the limit of t approaching infinity. Yeah, so we want to know when this will be equal to y bar. Yeah, because we want to know when the system will converge to the steady state value, which is equal to y bar. Yeah, so basically we want to make sure that this equal to 0, right? The limit is equal to 0. Yeah, and then limit yt will equal to y bar. Okay, and when will that happen? Yeah, of course, this will approaching 0. This will approach 0 when a is positive, right? When a is positive, then e to the power will serve as a divisor. Yeah, so as t is getting larger and larger, of course, altogether this term will approach 0. Yeah, it is different when a is negative. Yeah, so we have e to the power of something positive. Yeah, and of course, as t getting larger, as t gets larger, yeah, this term will also get larger. Okay, So, of course, yt converges to the steady state value y bar, which is equal to b over a, if a is greater than 0. Okay? Yeah? So now, the question, right? Okay, what is example 6? Let's go back. This one is the equation. Yeah. Okay, this is the equation. Remember, when the system will converge to the steady state value when A is positive. Yeah, when A is positive. Okay. Yeah. So what is the A here? Yeah, so if you don't remember, maybe I'll just rewrite the K accent here. Is equal to I bar minus delta K, yeah? Or if I rewrite in the standard form, is just K accent plus delta K equal to I bar, yeah? And remember here we have delta, which is positive, yeah? So A here is delta, and delta is positive, yeah? And of course, this is a positive value, yeah? So what does it mean? Yeah, it means here the solution, yeah, will converge to the steady state value, equilibrium, yeah. So the answer for this example is yes, it will converge to steady state value. Okay, that's the video for this topic, which is the initial value in first order differential equations, and we also learned about convergence of convergence to the steady state value. See you again in the next video.